Okay. My screen is visible now.
Yes, sir.
Yeah, we'll see in just previous class extension only. We'll start with uh, some test function solution, then we'll move on to MATLAB coding explanation also. As I said that there is a three phases. One is employed B phase, then onlooker B phase, then scout B phase. So apart from this, in this what we need is instead of finding only the function value, we need to find fitness also. The difference between function and fitness is just inversely proportionate. If our intention is to find minimum function value, so that is our question. Function value must be minimum. So in that aspect, you can find the fitness as well. If you find the fitness, that value must be high. Higher fitness will give as a minimum function value. So that is the, once if we calculate the function value and simply substitute here, we will get it as a fitness value. So once if you know the fitness, this formula will be used only your function value is positive. Your function value is negative, then you can use this formula. So this both is given, depends on our value of the function. How we will get the function value? Based on your values, variables. So suppose x1, x2 variables are known to you, that you can substitute it in function value. That function value will obtain. If function value is positive, then use this formula. If function value is negative, then you can use this formula. So 1 plus modulus of x will give you as a fitness value. So that is one thing to calculate as a fitness. And similarly, as I mentioned in the previous slide, there is a greedy selection. What is meaning of greedy selection is, before any operation, just random values are there, as I said in the previously. Once if you know the random values, we are getting as a function value as well. Then if you do some operation, there is a new function value will be obtained, whether it is a based on this implied B phase or onlooker B phase, both we need as a greedy selection. So any operation if we made using this, either of this, for both cases also we need greedy selection. So how to make it as a greedy selection? So for that, x is a old value, f also old value. Now after doing this implied B phase or onlooker B phase, you just find what is the new x and new function value. Means after doing implied B phase, you will get one variables x1, x2, x3 and so on. How many variables are there in your function, that variables will obtain. And as well, once that variable is substituted in a function, you will get it as a function value also. Now you after that you can directly find the fitness value by using this formula. Once if you know the function value, you can find the fitness also. Now what you want to compare is, suppose previous fitness value and this fitness value we need to compare. If new fitness value is more than old fitness value, you can modify your values. So what is the modification? Previous x values is discarded and new x value is assigned to that. And similarly, function value also. So previous function value is replaced with the new function value. So this is the procedure we need to do for a greedy selection. Or else means, otherwise what, if your new fitness value is lesser than the old fitness value, you simply retain the previous value. So this is the very important for all other algorithms, not only ABC algorithm, any other algorithm you can consider PSO or anything, whatever you can consider. So only inside, when you are doing operation, whether we are going right direction or not, you are selecting. So like a betterment exam, once suppose you got some B grade first attempt, if you write as a betterment exam, if you get as a grade, They will compare the two grades, which one is better, they will take it. So the suppose if next time is a C grade, if you get, then the B grade will retain assets. Like that, once if you do operation and the new values will get, that you compare with the old one, and based on that you can select the solution. Now here in terms of fitness, a higher fitness is a better solution. Or if you want to compare function value itself, this is also fine. Only the thing is f new, if you want to compare only the function wise, I don't want to go for fitness. If that case also fine, the new function value is always less than the old function value, because in the our object is a minimum function, no, that's why you can use this relation. Suppose if any problem, like yesterday I mentioned in the one of the journal paper, stability improvement, in that case what you will do is the improvement is a maximization problem. In that case you can keep is a greater than case. If you compare the fitness, in that case you can use as a less than case. So like that. So slight modifications are required based on your objective function. So this is the greedy selection. Next, we'll start with employed bees phase. First we'll go for employed bees, then onlooker bees, then scout bees. So generation of a new solution. How the new solution is going to be generated? Let assume that some populations are there. Let it be some random variables we already pick up. That is some different steps we'll take it. Not only one solution. We will get based on your number of population. Here is the population, call it as a solutions. So we can take it as a sum. So in terms of the ABC algorithm, you can see that number of employed bees is equal to the number of food sources. So there is a different food sources are there. So number of employed bees is equal to the number of food sources. All solutions get an opportunity to generate a new solution in the employed bees. The partner is randomly selected. Partner in the sense, as I mentioned, no, X matrix is there. So randomly we will select some solution. Let for simplicity 4 or 5 solutions let consider. The variables also suppose x1 and x2 only. So I want to, for, or if you want x3 also there, you can take it like this, some values. Now first solution I want to modify any of your variable. It may consisting of x1, x2, x3, x4, x5 and so on, anything that depends on your problem. Suppose what I want to do is here any of the variable I want to modify. For that you want to consider the sum of the partner solution randomly. Partner in the sense neighbors, let consider. So this is the solution 1, there is another solution 2, then third solution and fourth solution, like that. Based on your number of populations you take it one of the randomly, because 5 is there. You generate as a code a random value 1 to 5, you can pick up any of random value that will consider as a partner solution. Suppose I want to modify the first solution, randomly you pick up any of the row, let it be fourth one or third one, but should not be first, because if you generate the random value 1 to 5, if it picks up again 1, again you do one more random, because 1 and 1 may not be the neighbor, no. So that's the reason first solution we are doing, and you have to pick up as a random one, and the random must be, should not be the same as the ith one. So then like that you can pick up the random and you have to do operation. That only I mentioned here. This step is very simple step. Some x value let consider. This is our going to modify any of the variable, and partner solution you can pick up from that matrix other than that current solution, and which element I want to modify, that also you take it as a random, because all these things will implemented through MATLAB code. You just how many values are there, 4 values are there, you make it as a random of 1 to 4, then in that any one of the randint we can use it that in that any one of the value will pick up, that corresponding value only we are going to modify, not all the variables according to this algorithm. Now let consider that random value we pick up as a second one. So what is second one? In this case is a 1, and in this case is a 4. So using this formula, what is the formula? This is a new solution formula. To get as a modified value, what I want to do is xj new in the sense the current upcoming value what you want to modify, and j is a which element you are going to modify. Here I consider as a second element. In that xj, this is a old one is a this one, and phi randomly we are to generate. Phi is a random generation between -1 to 1. Just you know the logic for MATLAB, randomly generate a value between two values. So use that formula, you can get it directly, or command you can use that, you can get it as a random value between -1 to 1. That is as per algorithm. Now in this case the value is generated as a -0.1. If you run one more time, the phi may vary everything. This instead of second value it may pick up as a third value or fourth value, anything. That's why you can remember one thing: in all optimization algorithm, not only ABC, any algorithm, if you run once, one solution will get it. If you run another time or second time, third time, fourth time, and so on, no iteration will give the same answer. That is the reason. Reason is very clear, no? All values, many of the parameter will generate randomly. That's why what they will do is, in all the optimization algorithm, once if you develop the code, you run 10 to 20 times, and which is the minimum value, you take it that. So that value of the control variables is your final variables. That's why generally if you run only once and whatever value you are getting, that may not be the final solution. So the reason is randomly we are pick up in initial stage, no? That's why all these five values and many parameters will randomly change. That is the reason, and the number of times you run, which one will give as a better solution, that is your optimal value we need to consider. Now we can see that as per employed B phase, new solution has to be generated, and then you have to see that the new solutions are within the limits or not. The why we need to check that limits. Suppose if in a power system there is a power plant, generator limits are there, minimum is 10 megawatt, maximum is 150 megawatt, and the algorithm is saying that generator 1 has to generate 152 megawatt to get as a minimum cost or minimum loss or something, whatever your objective. Whether it is valid, algorithm is saying that generator 1 has to generate 152 megawatt, but you cannot consider that solution. The reason is what? As you know that generator 1 limits are 10 to 150 or maybe some other value. So the algorithm will say something, you need to check it whether that value is within the limits or not. For that reason we need to check the limits also. So once how will you generate as a new solution, then I will let you know that how to check the limits. Now this is our old solution, this is our partner solution, therefore new solution is this formula. Now I will substitute that xj. What is xj value? Here I pick up it as a second value, no? So second value is what? 1. So xj is 1. I substituted, and plus 5. 5 has to generate randomly -1 to +1. In that case, in this case we get 5 value is -0.1. So substitute -0.1 into xj. What is xj? 1 only. Minus xp. What is the partner solution second value? 4. So you substitute 4. Then what you got? 1.3. So new solution is modified only this value, not all values. Then what I can write? X new now. This is a x new value. I can write it. Every value is same except that modified value 2, and the second value is modified here. Then what I can use? 1.3, then 6 and 9. That's all. Over. New solution we got it. Now all variables, these variables, let consider 4 variables, let x1, x2 and 3, 4, no, all four variables are within the limits or not. Suppose our problem limits are 0 to 10 for all variables. Some problems each variable will differ with their limits, like a generator case, power system case, generator 1 limits may be different, generator 2 limits may be different. So individually they have their own limitations. So now what you want to do is you need to check that x1, x2, x3 all variables are within the limits or not within the maximum limit as well as the minimum, both we need to check. Now for that it is simple. LB represent as a lower bound or lower limit, UB represent as a upper bound. Now we can check that. Second, all remaining is as usual. No? While you are generating itself, we are taking care of the within the limits, the formula itself. Now you modified the second one. Now you check that second one because remaining is as usual. We not change anything. If anything is changed, you need to check the limits. So now second one is within the limits or not. Now what is the value? 1.3. Now second one, if 1.3 is less than lower limit or not. If it is less than lower limit, what you have to do, or another condition you can see that that value, new value is greater than upper limit. So these two conditions we need to check. But what is our condition if anything is happened? The new value is, suppose if it is below the lower limit, what we have to do? Suppose if it is above the upper limit, what you have to do? So both is wrong only. It should not be below lower limit. It should not be above the upper limit. Then if you get that value is out of boundaries, then if it is violating the lower boundary, you make it as a lower value. Suppose our value is 1.3. Our upper boundary is 1, lower boundary is 0. What is violated? Let just for example I am telling, upper bound is 1, lower bound is 0. So our value must be 0 to 1, but our new value is 1.3. Let us assume that. Then what you have to do? I cannot keep 1.3. I have to keep 1 only. If upper bound is violated, you adjust it to upper value. If lower bound is violated, you adjust it to lower value. So this is the logic we have to write in a program. That only I represented the logic also here. So what I did is, if this value means new value is less than upper bound. If it is less than upper bound, what I have to do? That new value is equal to the upper bound value. Suppose if new value is greater than upper bound, see that this is less than lower bound, you have to adjust it to the lower bound value. If that new value is greater than upper bound, you cannot keep, no, it should not be lower, it should not be upper, it is always within the limits. So now you have to keep it into equal to upper bound. So this is the bounding. So that is only employed B's. First you have to generate new solution using this formula. Once if you get that new solution and check that new solution is within the limits or not. If it is violated, if it is a lower bound is violated, keep that value to the lower bound value. If it is upper is violated, keep that to upper value. That's the thing. And now you can see that once if you generate the new solution, what is the next step? As usual of previously, objective function you have to find, then fitness you have to find, all the things as usual. So now you can see that newly generated solution is there. For that you have to find the objective function. That means f you have to find. Once if you know the f, you can find the fitness value also. So then we are finding the fitness value. Then once if you know the fitness value, you go for as a greedy selection. As I mentioned previously, how to find the greedy selection? This is a new fitness value. Already you know that old fitness value. These two you can compare. If fitness new value is greater than old fitness value, then you can retain the new values. Just you modify it to the new values, or if it is less than that, you can retain the old values, like that. That is only the greedy selection. So as per the previous explanation, you can do the greedy selection. After that, trial count, there is a one variable you can create, that is a trial, or any other name you can use it, anything, that is only the variable name. And it will, suppose if it new solution is not selected, means new fitness value is not a higher value than the old one, that means what, that solution is not countable. No, we don't require that. That's why trial count you can increase by 1 if it fails. So number of failures encounter using trial count. Why I keep on tracking that, whether if you do the operation employed B space, if new solution is better, you can trial count is reset to 0. If new what we call it as new solution is failure, or in the sense it is not a better solution, then you can increase trial count by 1. With that you can keep on tracking the trial count. So that's what we are using as one variable as a trial count. So increase the trial of the current solution by 1 if new solution is inferior. So that means if it is not suitable, or it is not a count, or it is failed to update, then it is increased by 1. Otherwise, if it is a good solution or a better solution, then trial count will be reset to 0. This logic also we need to write it in a MATLAB code. Just we are seeing that we are comparing new fitness and old fitness. If new fitness is greater, then trial count is reset to 0. If new fitness is lesser than the old fitness, then trial count is increased by 1. So that logic we need to implement. Now that is all about the employed B phase. So how many phases we have? 3 phases. Employed B is one phase, and then onlooker bees, then scout bees. So these are the 3 phase operation we need to do. First employed bees completed, new generation you have to generate, then you have to check the boundaries, then the trial count, greedy selection we have to do, then you can keep track on the trial count. So for that you can see that same whatever I explained so far theoretically, that I will represent in the MATLAB logic. This is only the MATLAB algorithm, you can say that. So what are the requirement? Fitness function, lower bound, upper bound, number of population, let you can take it 5 population for simplicity our example case, and then food source. This is the number of food source is equal to the employed bees I already mentioned, objective function f, and fitness, then trial count. These are the variables you have to initialize. Then for 1 to np, because how many I mentioned no population solution, that is decided by you. In general application, power system application and all, will take it as a 50 something like that. Even if you want to take 100 also, it won't mind anything, it only the system will calculate. So now let consider if it is a 4 or 5, these are the and number of solution. Now let consider variables, control variables x1, x2, x3, x4 and so on, you can take it. So this is the first matrix, randomly we need to generate some values, whatever I represented dash, that means it is a value, some values. So these are the matrices available. Now first I is equal to 1. So first solution we are doing, means first row, it consisting of x1, x2, x3, x4. Our function value, let assume that x1 square plus x2 square plus x3 square plus x4 square, let consider. Then when you are taking as a first one, you need to select as a randomly one of the neighbor solution, and if neighbor solution is same as the first one, you do once again, you will get it as another value. So now substitute that values using this formula. This is already explained in the previous slide. So 5 you have to randomly generate between -1 to +1. Xj is a old one, any value which one you want to modify, that you can pick up, and partner solution based on your random selection of among all 4 or 5 values based on this matrix. No, that value can subtract, will get it as a new. After that, bounding. What is bounding? This algorithm also I specified coding also bounding case, whether here you can see that bounding code also will be available. And now after doing bounding, what you have to do? Objective function you have to evaluate, Fitness you have to evaluate. After that, whether the solution is accepted or not based on the trial count. If it is accepted, reset to 0. If it is not accepted, trial count increased by 1. That is the first solution. Similarly, repeat that loop. We'll go to the next solution. What is the I is equal to 2? Now second row. Again repeat same procedure. Second row, J we have to randomly select. 5 will be selected randomly, and partner solution. Now first one may be partner, or third one may be partner, fourth row may be partner, anything. It should not be second one. Like that, you select the partner solution and repeat that procedure until all the rows is going to be completed. Then what will happen? That is about the employed B phase. So now we'll go for as a probability. So in after completion of that all the rows, you have to find the there is a probability of the solution. So probability value of each solution under onlooker phase is determined as, you can see that undergo in onlooker base, you can see that probability. There is a the previous phase, we know what is the fitness of each case. All the cases we are doing, you know, all 5 or 6 populations we consider, each fitness is known to you. Use the first one, second one, like that, and so on. Fitness, first solution fitness is known, second solution fitness, because there is a fit one of matrix. You can save that results in the one matrix like a fit. The first row solution fitness, second row, third row, fourth row, like that. So for finding the probability of the first one, make it as a prob of 1.9. There is a formula. Fit of I, what is this value? You can substitute. And among all the values, which one is a maximum fitness? So that is the formula for that is a max of fit. If you write automatically in the matrix which is the maximum value, it will take it as a max of fit and plus 0.1. So now we'll get it as a probability of that. So now you can see that probability values of all solutions are determined before going to onlooker B's. First, employed B is completed. That 3 steps only. New solution, then bounding, then fitness. All these things you can calculate, and trial count. So that is for the employed B's. Now, after employed B's, there is a you determine the probability. So using this formula, you can simply determine the probability before going to onlooker B's. Higher fitness value will have a higher probability. So then fitness solution may undergo onlooker B phase for more than once. So that is the solutions will repeat many number of times. Now we can see that. So this is the onlooker B phase. Let's consider 5 solutions. 5 population we consider. So what? This one is a fitness formula. This one is a probability formula. We already come across this. Now this one is your new solution in case of a onlooker B. Here only one logic is behind this. When new solution will generate. Sometimes may not be new solution will generate. When there is R is a one variable, you generate R value randomly between 0 to 1, and if that R value is less than the fitness value or probability value, because we already calculated the probability. Let probability probe values we consider. So let consider some 0.3 probability, and this is a 0.7 probability. Another one is a 0.6, then 0.1, then 1. Let consider just for this case these are the values. So this is the probability. In the previous slide we already calculated as a probe of I. So this is the case of matrix. Now for each case you generate one R value, random value. So let R is equal to something will get. Suppose if R value is 0.6. What is meaning? So this random value is a 0.6, but probability is a 0.3. So you cannot consider that. So in R means that solution will not generate as a new solution. So now what we have to do is that will be discarded. So that is what I mentioned as a red. Means here random value is 0.6, but probe value is 0.3. So you can discard that. Again same onlooker B1. will generate another random value r. Now in this case is a 0.4, but probability value is 0.7. So this F2 will generate as a new solution. Is it clear? So again F2 will generate new solution as per this formula. Same formula again repeat that we will get it as a new solution for F2. Similarly, like that all the other variables onlooker B2, so it will generate one R value, we will check that probability. Here R value is more, that's why probability value is less, we won't generate any new solution. But second other case, other solutions you can see here, R is 0.2, probability is 0.1. Then what will happen? Probability value is a less, that's why it won't generate new solution. But whereas here you can see R value is 0.5, probability is 1. So that's why this onlooker B2 will generate a new solution for F5. And similarly repeat that, and further what is the repetition here? Onlooker B3. So because all 5 is over now onlooker B3 will see that F1 generate R value, any value it may generate. Now we'll check it whether it is R value is, let it be, suppose if it is a 0.4, let assume, and this is 0.3. Now it won't be. Then it go to F2. Then again R value and probability check it. If it is okay, then we can generate. Otherwise, you will go to next. So if it is fine, then onlooker B4 will go to this. Like that, you keep on doing that process. Now we can see that onlooker B3 random value is 0.1, but probability is 0.3. Therefore, new solution will generate. And similarly, that's what I mentioned, all these things. So what is that? Food source onlooker B1 means that row food source is F2, and B2 food source is F5, and onlooker B3 food source is F1, like that. So which one is satisfied, that will be represented, the new solution is going to be generated. So that is the first step in case of a onlooker B. And now same thing we represented as a algorithm. That's what the onlooker B. What you will do is you can keep on checking that whether it is a greater than or a less than. So you can see that again once if a new solution is generated, remaining procedure is as usual of employed B's only. What is the remaining? Once if you new solution is generated, you have to check within the boundaries or not. Once it is within the boundary, then go for as a fitness function value, and fitness value you can see that function value and then fitness value and then greedy selection and then trial count. So all the remaining procedures as usual of a what you call it as a employed B phase only. So that repeat all the things and you can complete that onlooker B phase. Now we'll go that limit criteria is here. Limit is user defined integer value. Now suppose every solution is associated with individual trial count, because we keep on tracking the trial count, how many times it is violating, all these things. There is a track record is there for from onlooker B onwards. If even employed B onwards, if there is a trial count in employed B but onlooker B it is satisfied, reset to 0. So that way also you can do it. So like that. Now we'll move on to scout phase. So solutions with the trial greater than the limit are that candidates to be discarded. So that means we are keep on tracking the solution 1 trial count, solution 2 trial count up to solution 5. In this case we consider 5. Then what we want to do is if any solution is having a higher trial count, that solution is going to be discarded and new solution is going to be generated, even though that solution may be better solution among other solutions, but if trial count is higher, then automatically that is going to be discarded. That's what the meaning here. Trial count generate more than some limit, we will set that maximum limit also in case. So that solution is going to be discarded. One solution with the trial greater than the limit is replaced with a new random solution. Now, if suppose all five solutions, they have their own trial count. Let it be trial count for solution 1 is maybe 0, and solution 2 may be 1, solution 3 may be 5, and solution 4 may be 2, and something like that. Then what you want to do, which one is having a higher trial count, that solution is simply discard and replace with some random generation value. That's it. So very simple logic here. We can write it in code also very simply. Just monitor trial count or max of trial count will give the particular, that solution will can simply discard and replace with random value of generation, like what we did in the first step, random generation between the two numbers, we can easily replace it that. And trial count of newly included solution is reset to 0, because that third solution maybe trial count is 5. Now I deleted that, and new solution is replaced with through random generated values, and obviously the trial count 5 is reset to 0, because previous values only for that trial count is 5 but not new one. That's why once you replace that value, you reset to trial count is equal to 0. And all that is the performance of the trial count. And now how to squad bees, just I explain, no, random between lower limit and upper limit, this is the formula. Let consider LB value and UB value, or is rand value, you can use it. So then generally you can use this formula, automatically new value is going to be generated. This is the code for pseudo code for scout bees. So now I given all the pseudo code, and you can implement this through MATLAB. And before going to MATLAB code, I will show that one small example of problem. I will take function how to implement manually using this scout B phase. Using all the three phases, or you can say that using ABC algorithm. Now we'll see one by one. Before that, there is, if suppose limit is 5, then you can see the trial count is here is less than 5, because trial count is 4 here, and here trial count is 0 and trial count, but here you can see the trial count is 6 for this solution. So what you have to do, scout phase, this solution will discard and new solution is going to be generated. Suppose some other case, you can see here is trial count is 6, but here site count is more, trial count is more 7, that's why here scout phase is enter. So like that you can change, the depends on our problem. Now these are the complete ABC algorithm, all the 3 steps I mentioned. Start the iteration and perform the employed bees, then perform the onlooker bees, then perform the scout bees. So individual what I call it as pseudo code I given, no, individually how to do the employed bees. There individually we have new solution generation, then bounding, then function value, then fitness value, then trial count. So these are the logic for all the cases. Now only in the scout B, you see the trial count is higher, trial count you discarded and new solution is going to be generated. So this is very simple logic. What I shown yesterday, that elsewhere paper, that paper we can easily solve once if you know how to do the problem or a function value here. So there is, you can able to do one big project, or if you solve that elsewhere paper itself as a big project. So now this is our function. If you want to solve that elsewhere paper, only different is this function is replaced with that variables. That's it. That much easy once if you know this thoroughly, if you understand. So now what I am doing is, let's consider sphere function. Name of this function is a sphere function. You want, you can change this to some other functions also, like I shown one of the journal paper in 2007 paper. There is a lot of test functions I shown, no, any of the test function you can replace with this. So here cleanly observe that problem first. What is the problem? Our problem is minimization of your function. What is the function? Summation I is equal to 1 to 4 xi square. That means if you expand that, what will happen? They already mentioned I is equal to 1 to 4. So if you expand this, x1 square plus x2 square plus x3 square plus x4 square. That's all. If you want to modify it, you can make it, this is 10 also is fine, because while you are doing MATLAB code, anything you can use it, but only manual calculation I am telling now. If it is a large values, it will take time. That's why just be taken as a 4 values. Now consider x1 square. This is our function now. Our intention is to find what is the function value. What is that minimum function value, so that what are the control variables x1, x2, x3, x4, you have to find such a way that x values, if you put it in the function, you will get minimum value. That's all. Now in our case, electrical engineers, what they will do is, this function is replaced by f of pgi, where I is equal to 1, 2, 3 and so on. We will get ai pgi square plus bi pgi, means pg1, pg2 and so on, plus ci. If we use this function, our power system problem will solve. That's all. So that is the reason I taken as a simple mathematical expression. We are solving using ABC. Now if we replace this, what we are unknown is, here is x1, x2, x3. No, in our case, what is unknowns? Pg1, Pg2, Pg3, Pg4 and so on, because number of generators are specified based on our problem. IEEE 30 bus system, as I shown yesterday, there is a 6 generators are there. You can use that 6 generators, PG1, PG2 up to PG6, if you find, like x1, x2, x3. No, if we expand this up to x6, that problem and this problems are same, like that. So that is similarities. That's why easy to understand this problem. Now I taken as a, in some books they represented s is equal to 10 and all populations are s by 2 is formula, number of population. You want, you can directly take it as a np is equal to 5. That is also fine. Now according to first step, here you can see that generate random solutions. How will you get the generate random solution? First is, let I consider 5 populations. So 5 random solutions I want to generate. What is that formula? In MATLAB, there is a rand between limits also mentioned. These x1, x2, x3, x4 values should not beyond these limits. It is always within 0 to 10. That's why we have to generate the random values, x1 to x4 values. You can see the first random value, the system will generate automatically whatever may be values. Once if you repeat that, another values will come. That's why, just if I taken that, what I have, x1 is 4, x2 is 0, x3 is 1, x4 is 4. That is the first solution. If you want, you can write here x1, x2, x3, x4 and so on. x3, x4. This is the x values. And like that you repeat that for loop, or even that colon if you use, you will get it as a any number of solutions. I want 5 solutions here, so I generated as a 5 solutions over. That is our first step, randomly generate the solution. Once if we generate the random solution, what is our intention? Find the function value. Well, how will you get the function f? Here 80, 140, 35 and all, how you got this value? These values if you substitute here, you will get it 81, and this values if we substitute again here, you will get 140, and this, see that 0 square plus 3 square plus 1 square plus 5 square, that will give as a 35 and so on. Now you can see that this is, the step is very clear. Just generate random values by hand calculation. You write it, these values are some values as you wish, and put that into function value. You can get it as a function values. But while you are writing, these values should not deviate from this 0 to 10. You can check it any value, all values within that limits only, 0 to 10 only. Now next is what? Once if you know the fitness, function, you find the fitness. How will you get the fitness? Using this formula, I already explained. Your function values are this one, no, 81, 140, 35 and so on. 81 is our function value, therefore it is a positive. Use this formula to get fitness. What is the fitness? 0.5 not 122. And if you substitute 140, fitness is this, and so on. If you substitute 35, you will get fitness is this, and 120, I mean 102, you will get this. Using this formula, you will get this matrix. Now that is another step is completed, calculation of a fitness. Then what? Trial count I mentioned now. After getting fitness also, trial count means while selecting as a new solution or a greedy selection case. So initially all the trial counts are 0 because we are not checked now. Now we are going to check. Now what is the fitness of new solution? When you will get it, that by doing as a employed base. So now initially we created as a one trial count, all values are 0. Now we'll start our employed base. So far what I did is only the random selection. Simply you select as a random values and put it that values in a function. You will get the function matrix. Then after getting as a function values, put it in fitness function formula, you will get the function. Now you create one trial count, that is another matrix or empty matrix. Simply you keep it as all trial counts are zeros. Now we will move on to phase Y phase. Now I move on to employed B phase. So first all whatever I explained so far up to first step 1 to step 6, whatever I mentioned here, number of steps, all the things are initial stage only. Now real ABC algorithm is started here. So what this started, as you know that new solution, first itself you have to find the new solution. How to find the new solution? Using this formula. So for the first solution, we are modifying any of the variable. That variable number must be randomly selected. That case in here, third value is going to be selected randomly. And now partner solution also you have to select randomly. That's what random partner solution is taken as a fourth one. That is your choice, anything. Somebody want to take second, you take it, and that value will be 9 here. And in this fourth case, fourth row, third value is 4, no, that's why they taken here random J. This is a J, as I explained previously. This value is going to modify according to this formula. Then what is the modification? Phi is also randomly generated between -1 to +1. Then the value is 0.81, and finally you got the value is -1.43. Now you keenly observe the problem here. What is our limits? X1 to X4 limits, as I mentioned in a problem, the limits will be 0 to 10. But what we got? -1.43. So this -1.43, next step after generating is a new solution. What is the next step? I told no, bounding. Whether this is within the limits or not, we need to check. While you are checking the lower limit, it is violated. So value, lower value is a 0. That means any new solution should not deviate beyond the limits. It will be always within the limits. So now I got -1.43, but it should not be. Then what I have to do? You have to modify that value to lower value. So instead of 0, I mean instead of -1.43, keep it to 0. That's all. That's what I mentioned here. This is wrong because it is violated that limits. So you have to bound using this formula, and you can replace that value to the 0. Suppose if it is this value is 11. Let us assume that this value, after calculation of that, this value if you get 11, then also problem, because limit is what? Only up to 10. If you get 11, then you make it to 10. That's all. So now if lower limit is violated, set to the lower value. That is single statement. That is the now. Once if we set that bounding, what is next step? Anybody? Next step is function value, then fitness value, then greedy selection, then trial count. That's all. Very simple thing. Now this is our new values. We go with function value. What is function value? 4 square plus 0 square plus 0 square plus 8 square. That will give 80. Previous case it is 81. Now function value is a 80. Then go for fitness. Fitness previously 0.0122, but now 0.0123. Now fitness is improved. Then we find the function value, then fitness value. What next? Greedy selection. So greedy selection, what it will do? That fitness values will compare. This is a new fitness, this is a old fitness. So which one is high? You select that. So now automatically new fitness value is more, then I can say that this one will be the higher fitness than the, while the greedy selection values, these values are replaced by these values, and this function value is replaced by this function value, this fitness value is replaced by this fitness value. Now you can see the first row, all the things are modified. Previously 4018, now 4008. The function is 81, now function is 80. Fitness is 0.0122, now fitness is 0.0123. Count is what? 0 only. Why it is make it 0? Because new solution is better solution. That's why we take a new solution. Suppose if new solutions are not better, then you increase the trial count by 1 and keep this solution. These values will be as such. You can use these values as such, but trial count increased by 1 if new solution is a worst one. But in this case, new solution is a better one. Like that, you repeat all other populations. This is all about only the first one. No, we did first one. Now you can go for second one. So what is the second one? Repeat exactly same. You take it, these are the variables, second one, and you select any one as a partner. Use the formula for new solution. You will get the new solution. Then bound it. Then find the function. Then the fitness. Then greedy selection. Then trial count. That is the sequence. Now we'll see that second solution I taken. This is our second solution, and in that randomly select the j. In this case now it is picked. First one is a random selection. Then partner solution we have to select. Then third solution is partner solution. We got it. Then these two you can find new value. Phi is randomly generated between -1 to +1. In this case we got it 0.19. Then you can see new solution value is 3.57. Now this two comparing, that is actual current solution and this is a new solution. Now replace the first one. This is 3, that is replaced by 3.57. Now bounding case, what will happen? It is a 3.57. Our boundary limits are 0 to 10. So 3.57 is within the boundary limits. That's why no need to modify anything. You can keep as such. So now our new solution got it. Then what next? You substitute this into function. What is our function value? You can find this is equal to 3.57 whole square plus 1 square plus 9 square plus 7 square. So if you do that, you'll get it as a some function value. After getting function value, we'll go for fitness. What is the fitness? That is a 1 by 1 plus function value. We'll get it as a fitness. So this fitness value you compare to this fitness value. If this one is more, then trial count is 0 only. If this one is less, then you can use only these values and keep the trial count is by 1. That's all. Now that only we did. Then this is a new solution. Instead of 3, now it becomes 3.57. Now function value is 143. Earlier you can see that function value is 140, but now our minimum function, no, now it is a worst solution. So 143.75, and fitness you calculate. What is fitness? 0.0069. Earlier fitness 0.0071. So now we can compare greedy selection. What will happen? Greedy selection, it is failed. The new solution is a worst solution than the current solution. This is our current solution. So that's why what you will do, the second solution will not change anything. We'll keep it as such to the previous one, but trial count is increased by 1. That shows that second solution is new solution is a worst one. That indicate that trial count one time it is failed. That's why we keep on tracking that trial is a 1. And like that, what next? Third solution you take it and you repeat that, and then fourth one, and then fifth one. If you do that continuously, third one, I think this will get as a better only. Yeah. So third one, you can see that there is a trial count increased by 1. That means old solution is better. And fourth one, and again trial count is increased, old one is better, and so on. The fifth one, trial count is 0. That shows that if you do, because I didn't do all the things, any 2 is same, and repeat that procedure and all other values will obtain. So now this is a implied B phase. Now up to now we got it, whatever the solution it is move on to onlooker B. Before going to onlooker B, what you have to do, there is a probability checkup. So now the probabilities formula is this, as I mentioned earlier. See, this is the solution after implied B's. Find the probability of first solution, second solution, and so on. 0.9. Fitness is this one. Maximum fitness among this all, maximum fitness is this one. No? You can keep on use that maximum fitness, and individual fitness value you can use it here. That will give as a probability. Now you will move on to onlooker B. So after implied B's, find the probability, calculation of probability value. By using probability value, you can find onlooker B's. Onlooker B's, you randomly generate the R value and you compare that the probability value. If R value is less than the probability value, new solution will generate. If not, that will discard.
Sir,
So like that, we'll move on to hello. Yeah.
sir, it's 2:20, sir. We have another class.
Yeah, okay. We'll stop here. You can give your attendance only.
Okay.